Imagine living during a time period in which traveling to the moon has just become a reality. Neil Armstrong and space rockets seem to be the only topics discussed on the radio. The idea of being launched into space is a concept that is new and terrifying, yet mesmerizing. It is the year 1970, and you are one of the three astronauts about to participate in the third lunar mission, Apollo 13, and manifest a childhood dream into reality. A couple of days into the journey, however, as you are looking out at the moon and see it gradually getting closer and closer, you feel the spacecraft shudder violently and hear the alarms panicking, indicating that there has been a serious malfunction. Apollo 13 is my favorite movie in science, as it not only shows the technological and scientific advances that took place during this time period, but also shows us the scientific thought processes that occur when something goes wrong. This movie is about three different astronauts, Jim Lovell, Jack Swigert, and Fred Haise, and their participation in the third lunar mission. The space rocket took off on April 11, 1970, and for the first couple of days, the mission progressed pretty smoothly. However, 2 days later, during a routine stirring of the oxygen tanks, there was an explosion due to damage and overheated electrical wires, resulting in dangerous levels of carbon dioxide accumulating in the space rocket. Also, because the fuel cells depended on the proper function of the oxygen tanks, there was concern that not only would there not be enough energy to land on the moon, but there also would not be enough energy to return home to Earth. Scientists from Mission Control had to scramble to find a solution to save the lives of these astronauts. From this, there are clearly direct implications of science, in addition to certain aspects such as NASA and the moon. There is mention of accumulating carbon dioxide levels and continued respiration of the astronauts. Additionally, Mission Control mentions the need to use the moon's gravity to basically push the astronauts back home because the fuel cells were damaged. However, I also noticed that there were indirect implications of science that were subtle but nevertheless important and could still be applied. For example, according to the journal article called Teaching Chemistry Using the Movie Apollo 13 from the Journal of Chemical Education, an organic chemistry reaction was implied throughout this movie, specifically regarding the carbon dioxide. Because of this buildup, Mission Control came up with the idea to use a lithium hydroxide filter that would essentially convert carbon dioxide to lithium carbonate and lower levels of carbon dioxide. Along with this chemical reaction, orbital mechanics and basic physics concepts such as inertia are implied during the takeoff scene of Apollo 13. The article Teaching Science Using the Movie Apollo 13 from Science Scope talks about what they call the hypothesis observation cycle and how it is used in the movie. From this, I gathered that the hypothesis observation cycle is essentially the creation of testable hypotheses from a list of multiple observations. This cycle had to be completed many times throughout the movie, as the scientists truly had no idea what had happened to the oxygen tanks and what caused the explosion. From these observations, from data readings and instrument readings, Mission Control had to create testable hypotheses. Ultimately, they determined, as previously mentioned, that they would use the moon's gravity to slingshot the space rocket back home, and they would use a lithium hydroxide filter to lower the levels of carbon dioxide in the space rocket. Although the movie Apollo 13 undoubtedly keeps viewers on the edges of their seats, it also includes very valuable scientific principles. Rockets, space, scientists, gravity, and the moon are all important topics covered in this movie. However, even though Apollo 13 was a tremendous scientific and technological advance for its time, it was ultimately careful observation and creation of viable and realistic hypotheses that led to a solution that saved the lives of the astronauts.